Hi, so today I'm going to talk a little bit about backtracking algorithm. So for backtracking algorithm, actually it is not always the most efficient algorithm. Most likely it's going to be both exponential in runtime as well as in space complexity. So if we have some other options to solve the same problem, for example, if we can solve the problem in dynamic programming or DFS, BFS, we might want to choose that algorithm because it can most likely control the runtime and n square or n cube. But for backtracking algorithm, is always going to be exponential in most cases. But sometimes backtracking algorithm can be very useful. We usually use it when we want to get every possible choice. For example, if we want to get a combination of a set, or we want to get permutation of a set, that can be really, really useful. So when we want to exhaust all choices of a given set of either integers or a given set of choices, we might want to consider backtracking algorithm. So as an example, I show a problem in my screen. This is problem number, I think 78 in lead code. So this problem is actually pretty classic as well as a pretty easy backtracking problem. So basically we're given a set of integers and we want to return all its subsets. So this is actually a very classic scenario where we want to consider backtracking algorithm. So basically, this is actually, I think, a pretty standard way of like writing a backtracking algorithm. So first we have a driver function. This is the function that we really want to like return the final result. We also have a helper function, which in this case I call backtrack or btrack. This is the void function. This is the function that does most of the work. So in this function, we have several parameters. So the first one is the result, which we want to return at the end of the driver function. And we also have a temporary vector or array list in Java, if you're using Java, um, to hold the temporary result we have got so far, which might or might not be complete. And in this case, we call it subset. And we also have several other parameters to determine the stop time or the base case of this backtracking function. And inside this for loop, this is what usually we're going to do in almost every backtracking problems. So for nums I or for the current number, we have actually two choices. So the first choice is we want to put this current element in the result or in the temporary result subset, and the other choice is that we don't want this number. So in this case, we first assume that we put this current element into the subset vector, and then we do a backtrack based on the subset we just obtained in the previous statement and here. And then after we do the backtrack, so after we do this recursive check, there's one thing to know that we have to pop this from the temporary result as well, because otherwise this current element will always be in the temporary result and we cannot actually achieve backtrack on that. And in most cases, if we don't do this kind of like a cleanup step, there will be a lot of problems. So we're probably going to have a lot of same numbers and different solutions that we want. So it's going to fail the program. So basically, a general strategy for backtrack is first assume the current element is in the temporary result, and then do the backtrack on the current temporary result as well as like the final resulting vector, and then remember to do the cleanup. So this is actually a very general strategy for backtracking functions. And one thing to note is that because in this problem, we're going to return different subsets of a given vector of integers. So for every subset, it have different lengths. So in this case, we use the length of the given, like we use the length of the subset we want to control what is the like when is the time to stop backtracking. So basically we'll loop through every possible length and then call the backtracking function once for every length. Of course, like for each call to the backtracking function, it might recursively call itself. So yeah, I think that is what I have for backtracking functions. And thank you very much for listening.